The SKP25 is the Siemens combination safety shutoff valve and regulator. Because of the unique combination of one device being a safety shutoff valve and regulator, the sizing is different than what you may be used to. The sizing of a standalone safety shutoff valve minimizes the pressure drop across the shutoff valve. The sizing of a regulator considers the inlet pressure and flow to specify a regulator orifice size. With the SKP25, the safety shutoff valve body is the orifice of the regulator. We need to think about the valve body size like we would think about an orifice of a regulator. The typical gas train has a gas pressure regulator and then two safety shutoff valves. For good control, the pressure drop across the main and blocking shutoff valve is minimized. The SKP25 gas train is shorter because now the regulator and the blocking shutoff valve are one component. Like sizing an orifice of a regulator, we now decrease the valve body size to maximize the pressure drop across the valve without going over. The smaller the valve body, the better the regulator function will perform. Don't take too much pressure drop across the valve, then the top end capacity will be reduced. Since we don't want a size too small, it's important to know the inlet pressure to select the proper valve size. Commonly, the shutoff valve size with the SKP25 will be 1, 2, or even 3 pipe sizes smaller than the typical shutoff valve size. The higher the inlet pressure, the smaller the valve body gets. The SKP25 is a reducing regulator or a ratio regulator. In the picture, you can see a round diaphragm at the top. You can see the port on the front is labeled air. This port is when being used as a ratio regulator. The gas sensing port is on the back. The brass plug is for the spring when being used as a reducing regulator, or a bias spring for a ratio regulator. For doing the math on the sizing, we have a nice Excel program to do the work for us. The link to this Excel program can be found in the video description. This program is a questionnaire format that lays out the bill of material for you. I highly recommend it. Here is an example report from the program. It lays out the bill of material with a schematic drawing. There's engineering data on the right to get a feel for the minimum required pressure. Knowing the minimum required pressure helps you get a feel for how much wiggle room is available in terms of available pressure. For calculations by hand, we'll go through a short example. In this case, we have 2 psi inlet pressure and 5 inches water column gas pressure required at the burner. This gives us a 50 inches water column of available pressure drop. The goal is to size the shutoff valve to take as much of the 50 inches water column available pressure without going over. We have here a 2 million BTU per hour burner. Now let's look at the sizing chart to see how small our shutoff valve can go. Here is the sizing chart for Siemens double valves. Our 50 inches available drop and 2 million BTU per hour are marked in red. Our smallest double valve of 1 inch would be the answer here. The 1 inch double valve takes just over 10 inches of drop, which is well below the 50 inches differential available. For reference, under these same pressure conditions, a 1 inch double valve can flow up to 4 million BTU per hour. A typical 4 million BTU hour gas train would use a 2 inch double valve. And now with the SKP25, we would use a 1 inch double valve. So you can see the difference. The SKP25 requires an external gas pressure sensing line into the pipe downstream of the shutoff valve. We recommend 5 pipe diameters of straight run upstream of the sensing point and 2 diameters straight run downstream for clean pressure sensing. We also recommend keeping the velocity downstream of the shutoff valve less than 120 feet per second. Usually the pipe size downstream of the shutoff valve is increased. Thanks for tuning in. Any questions, feel free to contact your SCC account manager. We are here to help you. Thanks.